or the core one. So I'll give you a core update first, and then I'm going to talk to you about, I just got back from a space show. So I've been busy building my log cabin off grid, and we got the shell up, and there's still tons of work. So there's a lot of work that I have to physically do myself, but I'm getting back into doing the core one stuff. I sent Dimitri a Lattice dev board, and we're wrestling with Lattice to get him a license. Lattice is starting to really piss me off. So I ran across this new FPGA vendor. I'm going to start my video. Hopefully things don't crash. Ethenix. This is a board you can get off a DigiKey. It costs $75. I downloaded their tools. All their tools are free. Thank God they don't play the licensing game. That's such a headache. With all these vendors, licensing is such a headache. I've told many of these manufacturers, what are you in business for? Selling software or chips? Hello? Give the damn software away. Stop screwing with us. Anyway, it falls on deaf ears. But these guys went ahead and made software free. If you send them an email right now, if you go on their website, you buy a dev board, you put in the dev board type, and you can download it free. But if you send them an email to their customer support, you can actually get a link for free. So Core One, we should have some future progress over the next 30 days as we get spooled up. I may wind up switching the board to these guys. This is the kit. Okay, so I went to a show. Let's see, I'm going to capture the screen. I've been in Washington, D.C. all week. Come on. I must have grabbed the wrong screen. Let me try it again. Where's the entire screen? Okay, I guess you're seeing the conference screen, right? It says Satellite 2025. Is that true?
Yes.
Okay. So I went to Satellite 2024, just finished up on Friday. I work for a small engineering company called Next Stage LLC. There's 25 engineers. They've been mostly doing systems engineering for NASA Goddard and NASA JPL. They brought me on full time to do FPGA space computers, and I've developed my first one. I just got the board in the day before I left for the conference. So one of the things I asked all over the conference, because NASA has said they want to be able to reprogram, satellites and ships in space. So I walked around the show. You guys heard me say it a million times. You got 100 satellites out at Pluto. You need to upload and update all the software and all 100 of these robots over a 750 character per second data link. How are you going to do that? And I get a blank stare or a laugh, or my two. I never get an answer. So in the C world, you change one line of code, you have to recompile the whole thing into a binary blob, which could be hundreds of megabytes, and you're going to send that up 750 characters per second data link? No. Forth is the only thing that I know of, that has an incremental compiler. So I've talked to the president of NextStage about the Core One project. He loves it. So we're going to be over the next year or two getting the Core One into space because it's the only thing you could do incremental compilation and have an interpreter and incremental compiler on board. And FPGAs are the preferred processor for space systems today. They've pretty much pushed aside space-rated CPUs. They run faster. They're more parallel in nature. So I think there's a big opportunity here. One of the other talks I went to at the show, there were several AI talks, and space people are very concerned with the fact that if you use a large language model type AI, you don't know how it came up with the answer. Nobody knows. They just train these things and the answers come out. And they may or may not be right. So the space community is very nervous and not going to put LLMs in space. But, you know, something like an expert system, you know, that's written in Forth, they would, you know, something that's predictable and deterministic. That's what those are two key things. They don't want anything on their spacecraft that they don't know how or why it works. So it's a pretty fascinating show. I had 100 flyers. I came back with 4 of them. The exhibitors were basically a very target-rich environment, and I talked to one lady who's on the AI board, and I was talking to her about my triune brain, and she really thought that was very interesting and we weren't able to catch up, but she was very interested in that. So I think bottom line is there's a lot of opportunity for Forth to get back into space and longer term dominate space. So you can 5 years from now we can see if I'm right. So I guess that's pretty much it for me.
I have a couple of questions, Tom.
Somebody got a circus out there?
Brett, do you have background sound?
He was Brett.
Yeah, sorry about that. I was listening to 70s music on iHeartRadio. Sorry about that. I didn't realize it was playing. I kind of forgot. I just tuned it out. Hey, Don, I got a question for you about the Forth programming language. You were talking about tablets. Do they have virtual keyboards for programming language for hotkeys? So you can break out the commands or for the commands, like print statement strings, definitions and things like that you can program like the Forth or your chips and stuff like that much faster. Similar to how they have Voyager spacecraft where they have to come up with really quick fixes and stuff and then send it out to make sure it works. Or like when they were doing the lunar lander going around just recently, where they had to really come up with quick coding. Do they make virtual keyboards and stuff like that? I'm just curious.
Well, that's what a tablet is, right? A tablet keyboard.
Yeah, but
on your tablet.
Yeah, for a tablet keyboard, but it's a keyboard that has hotkeys. Does that make sense?
Yeah. Well, you know, you could create your own hotkeys on a tablet screen very, very easily, and that's what I was thinking when Brad was talking about ColorForth. Is a virtual keyboard you could implement any ColorForth type function, you know, and you could even reprogram one key to do something else the next keystroke. So it might be a better way to program in ColorForth. One of my very, very long-term goals after I get this board working, this board is for intelligent robots and playing around with the Core One. But longer term, I want to build I called it a fourth supercomputer that's basically, um, you know, basically a tablet with Core One inside, and more resources, more memory, a 10-inch touch, a 10 or 12-inch touch tablet, and then you would you could use the touch screen as a keyboard, or you could use a Bluetooth keyboard, like this thing. But
Yeah. I was actually looking into building FPGAs using some CAD software. I don't remember the CAD software is, but using FPGAs and building user interface like you were discussing, a tablet screen.
Brett, we're having trouble. Your audio's going in and out.
Turn your video off.
Let's see. Is this better?
Yeah.
I also had a earbud. Yeah, I was thinking about the same thing. I was thinking about creating an FPGA tablet myself to a degree for different applications. But what I really got started before that was to actually create a capacitor-driven battery to a degree, and that kind of got me on the line of thinking what FPGAs could be used for the capacitor batteries to building high computing FPGA systems like you're talking about, where it would store the data. I mean, it would store the energy and it would slowly be rechargeable by solar array. I don't know if that's already out there, really, I don't know. But the general gist is I thought about building an FPGA tablet using the CAD software, but the screen with using Arduino mostly, but also implementing the similar boards that you're talking about, that I can't remember what they're called, that they were using, that you mentioned to me when we first started doing this kind of thing. And
yeah, so the tablet that I want to build would be solar powered. It would work forever.
Yeah. Okay. Now it doesn't. Yeah, that makes a lot of sense. Yeah, just direct power. Yeah, that makes sense. Yeah. Now I got a question. How would you know how some things have to be in a case? I don't know the exact term for this, but in a case that hardens against the elements from radiation, from acid. Like if you wanted to go to Venus, it's such a harsh environment that you have to create a box or a case or whatever it is to protect it from the elements. How would you go about doing that, like protecting it from harsh elements and stuff like that? Kind of thing.
Well, it's so the FPGAs for space. I like the microchip PolarFire RT. RT's for radiation tolerant. Flash-based FPGAs are very resilient in space. The SRAM base, the Xilinx, flip bits all the time. So there was an article last week before the show about the new Mars rover was having so many bit flip problems using Xilinx radiation, quote unquote, tolerant FPGAs. Was bit flipping so much they went to the backup computer, and now they're having a similar problem with a backup computer. So chips that have to go into space are made using different processes, or at least you have to modify your process. The radiation is just a horrendous problem in space, but it's not only radiation, it's particles. There's neutrons and electrons and protons flying around. And
as much as I enjoyed it's out of scope. Chris has his hand up. He's been waiting patiently.
Oh yeah, okay, Chris, go ahead.
Yeah, great to hear about your conference in the space thing. So they just need one fourth processor. They need large numbers of them. They need barrel processors. There's a particular application they need. What's your take on how many cores they want and what they want to do with them?
So the PolarFire RT has 500,000 LUTs. So I mean, you could put hundreds of Core Ones in there, but as I said a lot of times, that's not the ideal way to use them. I use Core One sparingly, and I would have thousands of parallel processing, engines. Think like the vice drivers in an OS. All of those on an FPGA all running at 200 megahertz and all running in parallel, all asynchronous, all dealing with high-speed asynchronous data. So I will be working on this over the next few years. We had a tremendous interest in the system I'm developing. It's going to be very low cost. It's going to start at 50,000, go up to about 90,000 for a full boat computer. Give you some benchmark on that. When I worked at Redwire and I designed the computer, we spent $1.5 million designing the computer, and 2 years with 6 engineers. Now, I designed the computer, but other people designed like the motor control board and the power supplies and all that. So I'm talking about a complete avionics system, but it was $1.5 million. So what we're doing is they're going to be able to buy the computer off the shelf. And I went looking in 2019 when I first got put in the project for off the shelf rad hard FPGA computers, and I couldn't find any. So now I'm using NextStage, and they have 25 engineers with over 10 years experience. So that gives us the credibility, to actually get into this marketplace. So everyone was very excited about not only our FPGA computer, but I talked to them about the Core One and putting Forth on board. And they were I didn't hear any negative comments when I brought this stuff up. Many people didn't know Forth, but some of them did. There's a handful that had heard of Forth before. Usually they had gray hair.
Like everyone here.
So yeah, FPGAs are really the way to go in space.
There was a time when Forth was very popular in space. There's on the PIG website, there's a link to the archive.org representation of this NASA guy that listed as many as he could get permission for. I couldn't put anything on that list because of the company that I work for being obdurate about giving permission. There was a question on the chat about board vendor.
I didn't look at it. I'll take a look.
You mentioned the name of a board vendor. Can you just spell it?
Well, that's us. Next Age, NEXT Age, AGE. They're in Maryland.
There was some FPGA company you mentioned.
Oh, that would be Microchip.
Yeah, and there's another one before then.
Xilinx.
No, another one, a small one, a new company you said that just came out with a new board, and you like their software, you could download it for free.
DigiKey, Definix.
Efinix, thank you. That's it.
So I just downloaded their tools before the meeting started. I got the Core One to synthesize. I only had one error where we had set up an array that was 50 cells wide, and in our boot ROM, we had 52 line items, and it caught that. The other tools didn't catch it, which is interesting. So I just had to make the array 60, and it compiled. So Core One compiles straight out of the box on everybody's tools, which is kind of cool.
All right. With that, I'd like to ask Bob Armstrong if he's ready to go.
I'm ready to go.